My name is Akash and welcome to Spark tutorial on submitting and monitoring Spark jobs. In this tutorial, we are going to learn about two things. One is how to submit Spark job locally and in cloud. And second is how to monitor Spark jobs using Spark web interface. By monitoring Spark jobs, we are going to figure out common bottlenecks in Spark jobs and eventually learn how to optimize Spark job. So let's get started. I have a PySpark script over here called stockprices.py, and this contains the same code that we have been learning over the last few tutorials. Let's open this script quickly to see what's inside it. I'm going to be sharing this script in GitHub as well, so you can go and download it. So this is the code that we have. Before we get started, please know that you need to have Spark installed locally if you want to be able to submit Spark jobs locally. If you want to learn how to install Spark locally, please go and check out the tutorial that I've linked over here. In order to submit Spark job, all we need to do is write Spark submit command. And this command takes in few arguments. So one of the popular arguments that it takes in is called master. And this parameter helps you allocate the master node to the Spark job. So if you're running this locally, all you need to pass in is either local or local with asterisk. And what asterisk means is that please utilize all the thread to run this Spark job. Now, if you're running this in cloud, the first thing that you'll need to do is you'll need to log into one of the compute on the cloud. So let's say you have 3 different nodes in your Spark job. Log into your master node and pretty much you can run the exec command, or you can pass in the IP address after you log into your Spark cluster. So the IP address would be something like this, and then you're basically telling Spark that this is going to be the master node when you are running the job. So please go and submit this job to this node, whatever the IP address associated with this with the master node is, right? So in this case, we are going to be running it locally. But in cloud, just know that you might need to log in and then either assign an IP address or either log into the main node of the Spark cluster and then run the exact same job. So in our case, we are just going to be running the stock price.py script and hit enter, and it's going to start running the Spark job. Once you hit enter, you can go and monitor the status of your Spark job using Spark web interface. And the interface is usually located on the port 4040. So if you're running this locally, in this case, we are running locally. So we're going to be using the URL called localhost 4040 in order to access the Spark web interface. However, if you're running the Spark job on a cluster, then you would have a dedicated URL, in which case you'll need to type in the IP address of your master node, :4040, and you'll also need to expose that web portal to an outside request in order to access it. Now, I'm not going to talk a lot about how to do that in this tutorial, but you can definitely go and configure the parameter depending on the cloud that you're using to expose that portal. One interesting thing about Spark Web UI portal and cloud is that it is going to be available throughout the history where you can go and study your Spark job. But if you're running it locally, then the portal is only going to be available for the duration of running the job. And after that, it is going to go away quickly. So because our job is going to take less than a minute to run, we'll only be able to visualize the portal for a minute. And I'm going to first walk you through two things. One is what are the different parts of the portal? And then the second is how do we go and determine the bottlenecks in Spark job, right? So let me hit submit and let's go to localhost 4040. So this is the Spark job that we have. So over here, this portal is going to tell us how many jobs are running consecutively. What are the different stages of the jobs? In this case, these are the different stages: the storage, environment, executor, and the data frame that it generates. So in this case, I can go ahead and click on one of the stages. Now, because our script has finished running, we are not able to access it. So I'll have to go and resubmit the Spark script in order to access it. So let's go ahead and resubmit it. And let's access it again. Okay, so let's go to the stage and let me click on one of the stage over here. So once I click on this stage, what you can do is you can go and visualize the DAG over here and you can see what is happening under the hood. and see if there is any bottleneck in the tag by studying the tag. The second thing that you could do is you could also look at the amount of duration it takes to process this stage over here, and the amount of input size and shuffle that are happening over here, right? So let me go and resubmit this again because our job is taking way less amount of time. But the point is, I can go and monitor the different stages and how long it takes over here. And if a particular stage is taking longer, then I can go and click on detail, and then eventually, it's gonna guide me to the location where the job is taking longer, and then I can go and optimize it. So if you want to learn about how to optimize Spark job, please go and check out the tutorial that I've linked in the video over here, and then you'll be able to do that. Cool. So this is it for this video. Please let me know if you have any question. I will try to answer them as much as I could. And please subscribe to my channel. Thank you.